Thanks for reminding me. Okay, we'll continue with that next sum. Here, sum number 6. Okay, sum number 6. What is given? Under the action of 5 forces, the following system is in equilibrium. Okay. Determine the fifth force completely. Means out of that 5 forces, the 4 forces are given. Let this is F1, which is equal to 18 Newton. This is F2, which is equal to 22.5. This is F3, which is equal to 15 Newton. This is F4, which is equal to 30 Newton, incline at angle of 30 degree. This inclination is 45 degree. But this system or this body on which these 4 forces are acting is in equilibrium under the action of 5 forces. Out of that 5 forces, the 4 forces are given and you have to calculate the fifth force completely. Okay. Now for that fifth force, here the magnitude of that fifth force is unknown, F5. Its inclination is also unknown, as well as we also don't know to keep this system in equilibrium whether that fifth force should act in first quadrant, second quadrant or third quadrant. That also unknown. Okay. So in such cases, what you have to do? Here, let's assume this fifth force is in the first quadrant and making an angle of theta phi with horizontal. I am assuming that it is in the first quadrant. Means I am assuming that its x component, which is f5 cos theta, is towards right and y component is f5 sin theta phi will be upward. This is my assumption. I am assuming that it is f5, this force is in the first quadrant. I already told you that in the resultant, if any force is unknown, if its direction is unknown, initially you can assume that direction. With that assumed direction, you have to solve the sum. Here, and after solution, if you get magnitude positive, here then that positive sign indicate that the assumed direction is right. If you get negative, negative sign indicate that the assumed direction is wrong, and correct direction is opposite to that what we have assumed. So these are the assumed directions. So under the action of now these 5 forces, this system is in equilibrium. Here, so we can apply the conditions of equilibrium. Since it is in equilibrium, it must satisfy the conditions of equilibrium. And being as a concurrent force system, we can apply only 2 conditions, and by using 2 conditions, we can calculate these 2 unknowns, F5 and theta phi. Here, so let's use the condition of equilibrium. Using conditions of equilibrium, let's use the first condition, summation of Fx equal to 0. But to apply the conditions of equilibrium, you need to resolve the inclined forces. Here, one thing. Second thing, here for this sum, since it is in equilibrium under action of 5 concurrent forces, we cannot use the Lami's theorem. Lami's theorem is applicable only for the 3 concurrent forces. Here, if 5 concurrent forces are there, Lami's theorem is not applicable and you have to apply only conditions of equilibrium. Okay, so let's resolve the forces. Here, let's resolve this F5 also, F2 also into 2 components. This component is 22.5 cos 45 and this is 22.5 sin 45. I hope that all of you are comfortable with this resolution. Okay. The fifth force, its magnitude is F5 and inclination with horizontal is theta phi. So horizontal component is F5 cos theta phi here, and this is F5 sin theta phi. Here, let's resolve this F4 also into 2 components. It is 30 cos 30 and 30 sin 30. और किसी को डिफिकल्टी है क्या कि सर अभी तक मुझे रिजोल्यूशन ही नहीं आता है? Is there anybody who don't know the resolution at all? All of you are comfortable with the resolution? All of you are comfortable with the movement? है क्या कोई ऐसा कि जिसको resolution और movement नहीं आता है? Only 36 students are joined. 36 or at the most 40. There are the others. And that's why I am not uploading the video lecture from classroom. Because you are not attending the regular lectures and taking the advantage. So let's use the condition of equilibrium, summation of Fx equal to 0. Here this 18 plus 22.5 cos 45. Here plus F5 cos theta phi. This force is towards right, so positive. This component is towards right, positive. This component is towards right, positive. X component of this F3 is 0 and X component of this 30 kilonewton is towards left, so it is minus. Minus 30 cos 30 equal to 0. Here don't forget to complete the equation. Don't forget to write it 0. Here now in this equation, let's calculate this f5 cos theta phi. Here you will get the answer of f5 cos theta phi. Here means there are two unknowns, f5 and theta phi. Here we cannot calculate that two unknowns by using only this one equation. We require one more equation, and that we can get by using another condition of equilibrium, summation of f5 equal to 0. If I use summation of f5 equal to 0, let's start from this force. Its vertical component is 0. This vertical component is upward, so positive plus 22.5 sine 45. Y component of this f5 upward, so plus f5 sine theta 5. This force itself is upward, so plus 15, and y component of this 30 Newton force is downward, so minus 30 sine 30. Here, this is a summation of all forces should be equal to 0. Here, from this one you will get f5 sine theta 5. So these are the equation number 2. Solve 1 and 2, you will get f5 and theta 5. Tell me, how much is the f5 cos theta 5?
Minus 7.93.
Minus 7.93. Okay, now listen to me. Idhar dhyan do. Important thing. This f5 cos theta 5 is the x component of that fifth force. It was assumed, this direction was assumed. Yeah, so with that assumed direction, we got the negative value. So this negative value indicates that here the x component of that fifth force is not towards right, it will be towards left. Here, it means that this f5 cos theta 5, actually it is the x component of that fifth force. Okay, here which is equal to make it positive and show it towards left. This is the f5 cos theta 5. Okay, and how much is the f5 sin theta 5? अभी देखो कैलकुलेशन आपका फटाफट होना चाहिए. कंसीडर दिस एज अ एक्स, सॉल्व फंक्शन यूज करो, नेक्स्ट एक स्टेप में आपका आंसर मिल जाएगा विदाउट मिस्टेक. डायरेक्टली उसको f5 sin थीटा 5 को x यूज करो, सॉल्व फंक्शन यूज करो, नेक्स्ट स्टेप में आंसर. नो नीड टू शो द नंबर ऑफ स्टेजेस फॉर कैलकुलेशन. टेल मी हाउ मच इज f5 sin थीटा 5?
Minus 15.91.
Minus 15.91. Again here also this negative sign indicates that the y component of that fifth force is not upward, it is downward. Here for f5 sin theta 5 is equal to 15.91 downward. Here now solve 1 and 2. Here ये positive value use करो. Here so equation number 2 divided by equation number 1. f5 get cancelled, sin theta 5 upon cos theta 5 is tan theta 5. So tan theta 5 equal to 15.91 divided by 7.93. From this one you will get theta 5, substitute in any one equation, either 1 or 2, and get the value of f5. And its x component is negative, y is also negative. So for the equilibrium of this force system, that f5 force must be in the third quadrant. Okay, any doubt? Have you understood that? Now yesterday I told you about the flexible support. Here support given by the cable. Here, and whenever the body is supported with the help of some cable, here that cable or flexible support is always in tension. That reactive force is a tensile force. Here, its nature is tensile. Here, and that tensile force always acts away from the body under consideration. Acting along the string or cable and always acts away from the body under consideration. Understood? Okay. Now we'll solve the next sum. We'll solve sum number 7. Have got the answer? f and theta 5 मिल जाए क्या? Have got this answer or not?
Yes, sir.
हाँ, कितना आया f5?
17.78.
And theta 5?
63.51.
Okay. Very good. Now next sum. Sum number 7. अभी हम लोग listen to me. Till now the questions which we have solved, Here in that one, only one body was there which was in equilibrium. Here now we are going to onwards, we are going to study the equilibrium of the connected particles. Here when number of particles are connected together, when number of bodies are in contact with each other and that system is in equilibrium, then how to solve that sum. Here, so remember, when number of bodies are in contact with each other, here you have to consider the FBD of each object or each body separately. When number of bodies are in contact with each other, you have to consider the FBD of each body separately, draw the free body diagram and apply the condition of equilibrium separately. You can consider the combined FBD also. Understood? Yesterday I told you that. Why we are drawing the free body diagram? Just to expose the internal forces. ठीक है? लेकिन अगर कभी आपको अगर अभी जब हम लोग उसको सेपरेट करते हैं, या सपोज व्हेन टू बॉडीज आर इन कांटेक्ट विद ईच अदर, तो यहाँ पे एक रिएक्शन डेवलप होगा सिंस दिस टू ऑब्जेक्ट्स आर इन कांटेक्ट विद ईच अदर. अगर ये दोनों का टुगेदर कंबाइन एफबीडी लिया, तो दिस एक्शन एंड रिएक्शंस आर इक्वल एंड अपोजिट, कैंसल द इफेक्ट ऑफ ईच अदर. सो दिस बिकम द इंटरनल फोर्सेस जो कैंसल कर देता है. सो इन अ गिवन सिस्टम, इफ यू वांट टू reduce the number of unknowns here, so you can consider the combined FBD. Here इसको separate कर देता हूं तो क्या होगा, इधर का ये reaction और ये reaction that get exposed and number of unknowns will increase. Okay, here I will tell you that concept later, but remember when number of bodies are in contact with each other, you have to separate them and draw the free body diagram of each. Now we'll solve the sum number 7. What is sum number 7? A system of wires are given. Here if the cords suspended the two buckets in equilibrium position as shown in the figure, determine the weight of the bucket B. Bucket A has a weight of 60 Newton. Here अभी देखो ये equilibrium के समय even in resultant sum sometimes the weights are given in Newton. If it is given in Newton means it is a gravitational force and no need to make any changes. Here but sometimes instead of weight the mass is given which is in kg. If it is given in kg, you have to convert it into Newton. Here, so multiply that kg by 9.81 so that you will get in the Newton and use that Newton value here, that which is a gravitational force, in further calculation. Don't keep it in kg. Okay, so in this sum number 7, here one cable is there. This is one continuous cable. यार ये केबल को यहाँ पे एक बकेट कनेक्टेड है A और यहाँ पे एक B बकेट कनेक्टेड है. Here the weight of the bucket, now when these buckets are suspended, here that string will be in tension. Here अगर ये बकेट नहीं है तो ये स्ट्रिंग यहाँ पे और यहाँ पे जो कनेक्ट रहेगा तो it will form such type of catenary, isn't it? ऐसा catenary होगा. Okay, but when we apply some force here or apply some weight over here, here ये जो string था, here which was in the loose position, after applying the forces, here इसमें tension induce होगा, इसमें tension induce होगा, isn't it? Here, and the tension is nothing but a reactive force exerted by this cable on this bucket to hold it in equilibrium. Understood? Here, so all the three parts of that string are in tension. It is given that here if the weight of this bucket A is 60 Newton, calculate the weight of the bucket B and the tension in all the part of that string. Here you have to calculate the tension in all the three parts of the string. Okay. Now listen carefully. When I consider this FBD here or when I consider this figure, अगर मैं इसका FBD consider करता हूँ, तो इस पे ये string में का tension act होगा and that tension will act along the string and away from the body under consideration. Here, this is the T is the tension in the string EF acting along the string and away from the body under consideration. अगर ये point consider करता हूँ तो इसके away. लेकिन अगर मैं FBD of E consider करता हूँ तो tension in the string is remains same, magnitude इतना ही रहेगा. Here, but the tension acting on this point E, when the point E is under consideration, it will act away from the E. Here, this is also the tension in the EF, but this is the tension acting on E and this is the tension acting on F. Understood? Here, these two forces are two different forces. These are the two different forces. Here, एक एक्शन है तो दूसरा रिएक्शन है. These are action and reaction here which are equal in magnitude, opposite in direction and collinear in action. Understood? Here for example, suppose this is one body which is resting on this surface. Here इसका weight vertically downward act होगा and this body will apply, this surface will apply the reactive force in upward direction. This body is in equilibrium under action of these two forces and this reactive force is also equal to W. Clear? So एक action है तो दूसरा reaction है which are equal and opposite. तो ये same force नहीं है. These are the two different forces which are equal and opposite. अगर दोनों का combined FBD कंसीडर करता हूँ ये ब्लॉक का और सरफेस का, तो ये कैंसिल हो जाएंगे. I will not get that. और अगर मुझे ये रिएक्टिव फोर्स कैलकुलेट करने का है तो मुझे क्या करना पड़ेगा? I have to isolate this and I have to show the forces acting on this. तो मुझे R मिल जाएगा. Clear? So this is only the significance of the free body diagram to expose the forces. और जब तक expose forces नहीं होते तब तक we cannot calculate them by using the conditions of equilibrium. Okay, clear? तो यहाँ पे ये internal force हो गया अभी अगर मुझे ये टेंशन कैलकुलेट करने का है तो मुझे इसको एक्सपोज करना पड़ेगा. Now, how I can expose that? Here, so I can consider one imaginary section around this point F and I will isolate this. इसको जैसे मैं isolate करूंगा तो ये टेंशन और ये टेंशन एक्सपोज हो जाएगा and that I can calculate it by using the condition of equilibrium. Isn't it? समझ में आ रहा है क्या आपको? Are you getting it or not?
Yes, sir.
Okay. अभी देखो. So let's first consider the FBD of F. Okay, one more important thing. अभी F का FBD लिया तो आपको टेंशन इन EF मिल जाएगा as well as you get the tension in FC. FC केबल में का भी टेंशन मिल जाएगा. Now tension in the cable FC is remain same. Here, but its direction when I am considering the F FBD, it will act along the FC and away from F. But when I will consider the FBD of C, it will act along FC and away from C. This is also the tension in FC. एक एक्शन है तो दूसरा रिएक्शन है. यार इसका मैग्नेट अगर 50 न्यूटन आता है तो इसका भी 50 न्यूटन होगा. Because they are equal and opposite. Understood? Here now in this system, hello sir. In this system, yeah, these are the 2 points which are in contact with each other with the help of this cable. Here means it become a equilibrium of the number of bodies of system together. Here, in such cases, to find out the forces, you have to separate them. So हम लोग around F एक imaginary section लेंगे और F को isolate करेंगे. Around C एक imaginary section लेंगे और C को isolate करेंगे and we'll solve that separately. Understood? Yeah. Okay. Next important thing. In such cases, when number of bodies are in contact with each other, we are first consider the FBD of that body on which less number of unknowns are there. किसको पहले एनालाइज करना पड़ेगा. अभी यहाँ पे मुझे F का FBD लेने का है, C का FBD लेने का है, दोनों को सेपरेट एनालिसिस करने का है. तो किसका एनालिसिस मैं पहले करूंगा? तो फर्स्ट आई विल कंसिडर द एनालिसिस और FBD ऑफ दैट बॉडी here on which less number of unknowns are acting. अगर F कंसीडर करता हूं तो F पे 3 फोर्सेज है, 3 में से एक पता है, 2 ही अननोन है, which I can calculate by using the conditions of equilibrium or Lami's theorem since 3 forces are there. वही instead of F अगर मैं पहले C का FBD लेता हूं, यार ये C का FBD लेता हूं तो C पे कितने फोर्सेज एक्ट हो रहे हैं? ये वेट ऑफ B, ये टेंशन इन FC एंड टेंशन इन CD. अगर पहले इसको एनालिसिस करता हूं तो तीनों अननोन है. And for concurrent force system, we cannot calculate all the 3 unknowns. यार तो आपको क्या करें? अगर लिया भी आपने FBD of C तो wrong नहीं होगा, but you will get the 2 equation जिसमें 3 unknown होंगे and you won't get anything. Yeah, just you have to tell say equation number 1 and 2, फिर इसको एनालाइज करो, इसमें का जो वैल्यू मिलेगा वो इसमें सब्स्टिट्यूट करो तो आंसर मिल जाएगा. Clear? So instead of that, what I am suggesting, when the number of bodies are in contact with each other, first consider the FBD of that body on which less number of unknowns are acting. Here, so F is the point on which less number of unknowns are there. Here I have not shown the angle. This angle is 40 degree. This angle is 20 degree. And this is 65. Here this is also 20, alternate angle. Okay. So let's first consider the ABD of F. ABD of. Consider one imaginary section around F और उसको isolate करो. Now since it become a concurrent forces, since so reference X and Y axis दिखाओ. Which are the forces acting at this point F? The weight acts vertically downward, 60 Newton. Here tension in this FC. We know that the tension in the string acts along the string and away from the body under consideration. This is the tension in FC. How much is inclination? 20 degree. Here, the third force is the tension in this string EF. Here, this is the tension in the string EF, which is also acting along that string and away from the point under consideration. Its inclination is 40 degree with horizontal. In that point, F is in equilibrium under the action of three concurrent forces. Apply the Lami's theorem and tell me the tension in EF and tension in FC. Before applying the Lami's theorem, just cross-check. All the three forces should have the same nature. So, here all the three forces are acting away from the point, so no need to make any change. Directly apply the Lami's theorem and tell me the tension in EF and tension in FC. Using Lami's theorem. Okay. Here use the Lami's theorem. Roll number 6, Nilesh Birje. Are you there? Nilesh. Nilesh. Nilesh है क्या? Roll number 7, Dhanal.
Yes, sir.
Tell me. Look at the board and tell me the Lami's theorem. इसको Lami's theorem अप्लाई करने का है, बोलो कैसा आएगा इक्वेशन?
60.
हाँ, 60 करेक्ट है. गो अहेड.
Sin 120.
मल्टीप्लाई करूँ या डिवाइड करूँ?
Divide.
Divide. Here 60 upon sin of 120. आगे ये 120 ये एंगल आ गया है. Lami's theorem is the each force divided by sin of angle between others two. तो other two में का ये एंगल 120 हो गया है. 180 minus 60. हाँ, next go ahead. 60 upon sin 120.
TFC upon sin.
माइनस या प्लस आएगा या माइनस आएगा?
Plus.
प्लस आएगा. हाँ. TFC upon
Sin 130.
sin 130 करेक्ट. हाँ, आगे
TEF
प्लस या माइनस?
plus
प्लस. हाँ.
upon
TEF upon sin of
सर इज इक्वल टू आएगा सबके बीच.
इक्वल टू आएगा. हाँ, ओके, राइट. इक्वल टू आएगा, प्लस या माइनस नहीं आएगा Lami's theorem में. यार ये हर एक टर्म जो है ना इक्वल रहता है यार. मींस दिस इज it is proportionate to something. Okay, here so each force is proportional to the sin of angle between others two. Here equal आएगा, plus या minus नहीं. So TEF upon sin of angle between others two. How much is that? 90 plus 20, 110. Here इधर angle नहीं लिखा तो भी चलेगा. It is not that difficult to calculate angle between others two forces. Since we are drawing this x and y reference axis, तो हम लोगों को पता है ये 90 है. ये 90 plus 20, 110. Now equate first and second, you will get the TFC. करो fast calculation. Equate first and third, calculate TEF.
Sir, I have
Yeah.
answer.
53.07.
53.07 TFC. And how much is TEF?
65.1.
5.10.
65.10. Very good. Okay. Means the tension in the string FC, ये tension है 53.07. ये इसका ये इसमें इतना टेंशन इंड्यूस हो रहा है. यार जब इसका एफबीडी करेंगे तो यही मैग्नीट्यूड रहेगा, लेकिन अवे फ्रॉम दिस एफ. इसका एफबीडी करेंगे तो अलोंग दिस स्ट्रिंग सेम मैग्नीट्यूड बट अवे फ्रॉम सी, बिकॉज दिस टू फोर्सेस आर इक्वल एंड अपोजिट. Understood? Here, now consider FBD of P and analyze FBD of point C. Take the section around the C और इसको isolate करो. Which are the forces acting on C? This is the tension in CD. which is acting along the string CD, means it makes angle of 65 degree with horizontal. The weight acts vertically downward. How much is that? वही calculate करने का है, ये WB calculate करने का है. Clear? And third force is the tension in the string FC, acting along the FC and away from the body under consideration. लेकिन इसका magnitude अभी हम लोगों को पता है. How much is that? 53.07, making an angle of 20 degree with horizontal. Here again use Lami's theorem and calculate the remaining two forces, T, CD and WB. Dhruvit Chaudhary, roll number 08. आएगा? ध्रुवित, ध्रुवित, Suyesh Dadvi, roll number 812. Are you there? Suyesh Dadvi, Rohit Chaudhary, Rohit, roll number 11. Rohit, सी लॉगिन करके सो जाते हैं क्या तुम लोग? Only 2 or 3 students are answering. बाकी लोग क्या कर रहे हैं? रोल नंबर 18 ओमकार धुरी.
यस सर.
हाँ, टेल मी.
सर मैंने कंडीशन ऑफ इक्विलिब्रियम से सॉल्व किया.
No problem. Tell me condition of equilibrium. Very good. Need not necessary that you have to apply the Lami's theorem. If you are comfortable with the condition of equilibrium, you can go with the condition of equilibrium. जो लिखा वो बोल. C के लिए.
TCD.
हाँ, पहले condition बोल. Summation of fx is equal to 0. हाँ, okay. TCD
cos 65.
Very good.
Minus TFC.
Minus TAC का magnitude 53.07.
हाँ, is equal to 0.
नहीं, cos 20.
हाँ, cos 20 सॉरी सर, is equal to 0.
इक्वल टू 0, करेक्ट. यार अभी देखो ये इक्वेशन एक मिल गया है, लेकिन ये इक्वेशन में एक ही अननोन है, उसको इमीडिएटली सॉल्व कर दो इधर ही एंड गेट द वैल्यू ऑफ TCD. यार एंड देन टू कैलकुलेट दिस WB यूज समेशन ऑफ FY इक्वल टू 0. टेल मी द सेकंड इक्वेशन.
TCD sin 65.
वेरी गुड. TCD sin 65
minus 53.07 sin 20 minus W.
ये कॉस्ट कंपोनेंट आ गया, ये साइन आ गया. ओके, इसको रिजॉल्व किया. कंडीशन ऑफ इक्विलिब्रियम अप्लाई करने के लिए आपको उसको रिजॉल्व करना पड़ेगा. लैमिस थ्योरम अप्लाई करने का है तो रिजॉल्व करने का जरूरत नहीं है. ओके, फाइन, गो अहेड, कंटिन्यू.
minus W is equal to 0.
minus WB equal to 0. Here you have to substitute this value of TCD here, clear from equation number 1. Again use the solve function, WB मिल जाएगा. इक्वेशन लिखने के बाद में एक एक स्टेप में आपका आंसर आता है. ज्यादा कैलकुलेशन में अननेसेसरी टाइम वेस्ट मत करो. Clear, and make yourself comfortable by using that shift solve function. Clear, solve function अगर comfortable है तो एक एक स्टेप में आपका आंसर आ जाता है फटाफट. अंडरस्टूड. यार तो ये देखो लैमिस थ्योरम ही अप्लाई करना चाहिए, नॉट नेसेसरी. आप कंडीशंस ऑफ इक्विलिब्रियम भी अप्लाई कर सकते हैं. इनफैक्ट दिस कंडीशन ऑफ इक्विलिब्रियम इज एप्लीकेबल फॉर ऑल द कॉन्करेंट फोर्सेस, वेदर देयर आर 3 फोर्सेस और 4 फोर्सेस. क्लियर. लेकिन लैमिस थ्योरम सिर्फ 3 फोर्सेस के लिए ही एप्लीकेबल है. एनी डाउट? ओके, नेक्स्ट. नाउ नेक्स्ट वन इज सम नंबर 11. Draw the given figure properly. Listen, you have to be attentive. मैं किसी को भी पूछूंगा क्वेश्चन, क्लियर, प्रेजेंट रहना चाहिए और आंसर भी देना चाहिए. क्लियर. सम नंबर 11. Draw the given figure. This is very common and famous question in the exam. Here some cylindrical or spherical bodies are resting in one container. So here these are the 2 spherical bodies. Yeah, they are resting in one container. So both the surfaces are vertical. and base is inclined. Here, this is one container. Okay. Let this cylinder is P, this cylinder is Q. These are the center of that cylinder. This point is A, this is B, this is C, and let this point is D. This base is inclined at an angle of 10 degree with horizontal. Okay. Here, what is given in this question? Two identical cylinders. Here, these both are the identical cylinders. Identical मतलब दोनों का weight same है और दोनों का dimensions भी same है. Okay. Here, draw the figure properly. Here, this cylinder is touching to this base, but this cylinder is not touching to the base. Okay. Here, so what is given? Two identical cylinders, diameter of 100 millimeter and weight is 200 millimeter. Here, इसका diameter 100 है, मतलब radius is 50. Here, and weight of each cylinder is 200 Newton. Here, they are resting in this one container as shown in the figure, whose base is inclined at an angle of 10 degree. And the distance between these two vertical lines, horizontal distance between the two vertical lines, here are these two vertical surface, here is given as 150 millimeter. This is given as 150 millimeter. Horizontal distance between the two vertical surfaces. It is asked find out the reactions at all the point of contact. You have to find out the reactions at all the point of contact. All the point of contact means you have to calculate the reactions at points A, B, C, and D. You have to calculate the reactions at all the point of contact. Understood? Here, abhi dekho, these two bodies are in contact with these surfaces here and just touching the surfaces. Here, means all these surface support at point A, B, C are the smooth support. Now, since they are the smooth support, I told you that at the smooth support, the reactive forces, these surfaces will exert the reactive forces on that cylinder to hold them in equilibrium. And since these are the smooth support se reaction kaise apply hota hai? So at this point A, the reaction will be perpendicular to this surface and directed toward the body under consideration. यहाँ का reaction ऐसे आएगा, इसको perpendicular, ये इसको perpendicular, यहाँ का reaction ऐसे आएगा, इसको perpendicular. These are the reactive forces exerted by the surfaces on that body, isn't it? Have you understood? ये reactive forces कैसे आएंगे समझ में आया क्या आपको? These are the smooth support, and at the smooth support, the reactive forces are normal to the supporting surface. हाँ बोलो.
सर जो P वाला जो सिलेंडर है,
हाँ.
उसका भी तो फोर्स एक्ट होगा ना Q वाले पे? प्रेशर
होगा ना. मैं वो बोलता हूँ ना, मैं बोलता हूँ वो होगा. You are right. Yeah, but I am talking only about the external support. Okay. Then ये समझ में आया क्या आपको? RA, RB और RC.
Yes sir.
Okay. Now these two cylinders are in contact with each other at point D. Yeah, these two cylinders are also in contact with at point D. Since they are in contact at point D, so they are also exerting the reactive forces on each other. Here, ये इसको push करेगा, ये इसको push करेगा, and they are remain in equilibrium. Here ये action होगा, इसका जो force इस पे act होगा, that is action. और इसका जो इस पे force act होगा, that is reaction. Here, so at this point D also one reactive force is generated, isn't it? Because that surfaces are in contact with each other. Whenever the surfaces are in contact with each other, एक reactive force generate होगा. So at this point also the reactive force is generated. But this is the अभी यहाँ पे भी क्या हो रहा है? These two cylinders are just in contact with each other. They are not permanently attached to this one another. They are just touching to each other. So this support also becomes the smooth support. And at this point also the reaction कैसा रहेगा? The reaction will be the normal reaction. ऐसा रहेगा, यहाँ का भी reaction normal रहेगा इसके जैसा. Here, but यहाँ पे normal कैसा रहेगा? It is perpendicular to the surface. लेकिन यहाँ पे normal कैसा रहेगा? Here, so you remember one thing. Here, I would like to tell you one important point over here. So at this point of contact, here between the two spherical bodies, here the reactive force between these two spherical body acts along the common normal. इसका line of action कैसे होगा? Here इसका line of action horizontal या तो vertical नहीं रहेगा इसके जैसा. Here the line of action of this reactive force between the two spherical bodies, those spherical bodies to those circular body में जो reaction generate होगा, here उसका line of action acts along the common normal. इधर act होगा उसका line of action along the common normal. and common normal is the line which joins their center. यार अगर ये body ऐसे है तो common normal will be like this. यार if these two bodies are like this, the common normal is like this. यार तो यहाँ पे ये point of contact का जो reaction है it will act along this common normal. Understood? Here, so you have to write down this point which is very important. Here, write down this note. Write down reactive force between, write down this in your notebook, two circular bodies. Reactive force between the two circular bodies always acts along common normal. Always acts along common normal. किधर act होता है वो? It acts along the common normal. Reactive force between the two circular bodies always acts along the common normal. Here on that is, ये common normal मतलब क्या है? That is along the line which joins their center. ये दो सर्कुलर बॉडी का सेंटर जो लाइन ज्वाइन करेगा, दैट इज नथिंग बट इट्स कॉमन नॉर्मल. Therefore, that it acts along the line which joins their center. Okay, here write down this note in your notebook. So reactive force between the two circular body acts along this line, along the common normal, that is line which joins their center. Here have you understood this? तो यहाँ पे भी एक रिएक्शन आएगा. यार इधर देखो, when I consider FBD of Q, here I have to show the reaction exerted by P on Q. इसको RD consider करता हूँ. And when I consider FBD of P, I have to show the reaction exerted by Q on P. Here this is also RD. ये RD है तो ये भी RD है. यार ये देखो, ऐसा मत सोचो कि सिर्फ इसका डायरेक्शन अपवर्ड है तो ये RD है, आपने लिखा ठीक है, लेकिन इसका डायरेक्शन तो इसके अपोजिट है तो ये माइनस RD आएगा क्या? नहीं. यार सर these two forces are the, एक एक्शन है तो दूसरा रिएक्शन है, and according to the Newton's third law, this action and reactions are equal and opposite. Yeah, they are equal in magnitude. अगर ये +100 है तो ये भी +100 with this direction. अगर ये -100 है तो ये भी -100. Understood? They are equal and opposite. And किधर act होते हैं? They are acting along this common normal. Means if this common normal makes angle of θ° with horizontal, that RD, line of action of this RD will also make the same angle with horizontal, because that RD acts along that common normal. Here, have you understood this? यार वो दोनों दो सिलेंडर के बीच में का जो रिएक्शन आएगा वो किधर आएगा, ये समझ में आया क्या? Yes or no?
Yes, sir.
Yes, sir.
Then next, अभी ये दोनों में से ये सबको कैलकुलेट करने का है. अगर मुझे ये RA, RB और R6 को और ये RD को कैलकुलेट करने का है तो मुझे उसको एक्सपोज करना पड़ेगा. अगर मैं ये दोनों का FBD अगर एक साथ लेता हूँ, ये दोनों बॉडी का अगर FBD एक साथ लेता हूँ तो ये यहाँ का जो रिएक्शन है यार विच इज इक्वल एंड अपोजिट, तो ये समेशन ऑफ Fx के इक्वेशन में, समेशन ऑफ Fy के इक्वेशन में सब में कैंसिल हो जाएगा और वो मिलेगा ही नहीं यार, बिकॉज दोनों का अगर एक साथ FBD लिया तो दिस बिकम द इंटरनल फोर्स व्हिच विल गेट एलिमिनेटेड फ्रॉम द इक्वेशन ऑफ इक्विलिब्रियम. अंडरस्टूड? यार अगर मुझे नंबर ऑफ अननोन्स अगर एलिमिनेट करने का है तो यू कैन थिंक अबाउट दैट कंबाइन FBD का, लेकिन मुझे अभी इसको कैलकुलेट करने का है. इसको कैलकुलेट करने का है तो मुझे इसको एक्सपोज करना ही पड़ेगा. एंड हाउ आई कैन एक्सपोज दिस RD? यार बाय सेपरेटिंग दिस टू बॉडी एट पॉइंट D. इसको दोनों को सेपरेट कर देता हूं तो ये एक्सपोज हो जाएगा and it becomes the external force under which the body is in equilibrium, and I can calculate that by using the conditions of equilibrium. तो अगर कोई फोर्स इक्विलिब्रियम से कैलकुलेट करने का है तो उसको एक्सपोज करना ही पड़ेगा. एंड व्हाट इज द मेथड टू एक्सपोज द फोर्स? कैसे एक्सपोज करते हैं हम लोग किसी फोर्स को? उसके लिए क्या करना पड़ता है?
Drawing FBD.
ड्रॉइंग FBD. यार तो इधर भी हम लोगों को FBD ड्रॉ करना पड़ेगा. नाउ द क्वेश्चन इज, ये देखो आप दोनों का FBD साइमल्टेनियसली भी ड्रॉ कर सकते हैं यार, लेकिन एनालाइज किसको पहले करेंगे?
जिसमें कम फोर्सेस
कि जिसमें कम फोर्सेस है. अभी इसमें कम अननोन है. ओके, फोर्सेस नहीं, अननोन कम चाहिए हम लोगों को. ओके, अभी ये दोनों में से अगर सेपरेट FBD लेता हूं तो कौन से सिलेंडर पे लेस नंबर ऑफ अननोन्स आर देयर?
सिलेंडर बी।
Q.
सिलेंडर क्यू पे, या सिलेंडर क्यू पे ये आरडी और आरसी दो ही अननोन है, जबकि अगर पी को मैं पहले लेता हूं तो उसमें आरए, आरबी और आरडी तीन अननोन है यार, तो पहले क्यू का लेंगे। अंडरस्टूड? मैं दोनों का एक साथ ही ड्रॉ करता हूं यार। आई एम ड्रॉइंग द एफबीडी, ये क्यू का इधर ड्रॉ करता हूं और पी का इधर ड्रॉ करता हूं, जस्ट फॉर योर अंडरस्टैंडिंग। ओके, दिस इज सिलेंडर पी, दिस इज सिलेंडर क्यू। विच आर द फोर्सेस एक्टिंग ऑन क्यू? एक यहां से एक रिएक्शन आ रहा है, it is the reaction exerted by this wall of the container on the cylinder Q. This is RC. और एक बात याद रखना, when we are drawing the FBD of Q, या जो भी बॉडी का FBD ड्रॉ कर रहे हैं, you have to show the forces acting on that body, not by that body. यार this body कौन से forces की वजह से इक्विलिब्रियम में, वो इस पे शो करने का है। या तो this is one RC, other one is weight. How much is the weight? It is 200 न्यूटन यार। एंड थर्ड फोर्स कौन सा आएगा इससे? थर्ड फोर्स कौन सा एक्ट हो रहा है? रिएक्टिव फोर्स एक्सर्टेड बाय P on Q and that reactive force act along this common normal. यार ये along the common normal and directed toward the body under consideration, because at the smooth support the reaction is always directed toward the body under consideration. यार this is the FBD of Q. This is FBD of Q. Now let's draw the FBD of P. Simultaneously draw करता हूँ, फिर एनालाइज करेंगे FBD of P. Now which are the forces acting on P? Its weight act vertically downward, 200 न्यूटन। अभी ये देखो FBD ड्रॉ करते वक्त ही मैं क्या करता हूँ, देखो ये रिएक्टिव फोर्स मैं ऐसे ही ड्रॉ करता हूँ, डायरेक्टेड टुवर्ड द बॉडी अंडर कंसिडरेशन। ओके, आरसी और आरडी। अभी वेट जो है ना, वेट आप ऐसा भी दिखा सकते हैं, फ्रॉम दिस पॉइंट वर्टिकली डाउनवर्ड। लेकिन अभी मुझे अगर ये बॉडी को अगर लैमिस थ्योरम अप्लाई करने का है तो मुझे और इसमें चेंजेस करना पड़ेगा, इसलिए मैं भाई ड्राइंग द फिगर इटसेल्फ, ये डब्ल्यू इंस्टेड ऑफ शोइंग इट हियर, वो एफबीडी में मैं इधर शो करता हूं। डजंट मेक एनी डिफरेंस, ये सो दैट आई कैन अप्लाई द लैमिस थ्योरम डायरेक्टली। यार मुझे चेंज करने का जरूरत नहीं पड़ेगा, तो अकॉर्डिंग वो सोच के ही मैं एफबीडी पहले ही ठीक तरह से ड्रॉ करता हूं। अंडरस्टूड? एफबीडी ऑफ पी, this is the weight. The second force is the reactive force exerted by this surface on this P. Here this is RA. Here then at this point B, the reactive force is exerted by this bottom surface on this cylinder P. Here, and this is the normal reaction which will be perpendicular to this surface. It will be perpendicular to this surface. Here it is RB. Understood? Here it is normal to this surface. Now since this line of action is normal to the surface, if the surface makes angle of 10 degree with horizontal, what is the inclination of this line of action of this RB with horizontal? अगर ये इसको perpendicular है तो, अगर ये 10 है, अगर ये perpendicular है तो ये एंगल कितना आएगा with horizontal? 80 आएगा। Here it will be 80 with horizontal. ये एंगल 80 आएगा, isn't it? ये 80 है मतलब ये 80 आएगा, अल्टरनेट एंगल। Am I right?
Yes, sir.
Okay. Then the fourth force acting on this cylinder P is the reactive force exerted by Q on P, and this reactive force exerted by Q on P means at this common point will act along this common normal and directed toward the body under consideration. Okay. Now this reactive force is also RD. Okay. Yeah, these two forces RD, yeah, their line of action acts along, कौन से लाइन पे एक्ट हो रही है? They are acting along the line PQ. Yeah, their line of action acts along the line PQ, along the common normal. Yeah, and these two forces are equal in magnitude and opposite in direction. Understood? They are equal in magnitude and opposite in direction. They act along the common normal. Okay, here they act along the common normal. Here any difficulty in FBD? कुछ डाउट है क्या? Any doubt in FBD? Okay, ये समझ में आया, ये 80 एंगल्स कैसे आया? ओके, नाउ अभी हम लोग पहले इसको एनालाइज करेंगे यार। So we'll first analyze the FBD of Q. Consider FBD of cylinder Q. Now I can you calculate this RC and RD by applying the Lami's theorem for this, provided I should know the angle of this RD. यार इसका एंगल अगर पता है तो ही मैं ये दो कैलकुलेट कर सकता हूँ. यार I can calculate this RC and RD if I know this angle. And in such type of question, जब भी ऐसा सर्कल का सम दिखेगा, यार you have to calculate these angles by using the geometry of this figure. इसके लिए आपको फिगर का ज्योमेट्री यूज करना पड़ेगा. Okay, यार now we know that this RD acts along this line PQ. Line of action of this RD acts along this line PQ. If this PQ makes an angle of theta degree with horizontal, this RD will also make the same angle with horizontal. ये angle theta हो जाएगा because this line of action of RD acts along this line PQ. Okay, understood that? So let's calculate this theta. यार अभी ये थीटा कैलकुलेट करने के लिए join this center to center line. From this P draw one horizontal line and from Q draw one vertical line and construct one right angle triangle. यार ये standard procedure है. Okay, यार. So construct one right angle triangle over here to calculate the angle made by this PQ with horizontal. Consider this right angle triangle. Now in this right angle triangle, this hypotenuse is the center to center distance of that cylinder. Here, how much is this center to center distance, which is equal to the radius of this cylinder P plus radius of the cylinder Q. Radius is 50. So this is 50, this is 50. Here, so in triangle PQR, let this is R. Here, in triangle PQR, length PQ is known to you, which is equal to 100 millimeter. This radius plus this radius. Here, or it is 50 plus 50, which is equal to 100. PQ equal to 100. Now in this triangle hypotenuse तो मुझे पता चल गया. अगर remaining two side में से कोई भी एक side अगर मैं calculate कर लेता हूँ by using the geometry, I can calculate this theta by using trigonometry, isn't it? अभी वो right angle triangle में can you tell me which side I can get? PR मिलेगा या QR मिलेगा? So I can calculate this length PR.
थीटा मिल सकता है सर.
नहीं, विदाउट PR एंड QR थीटा नहीं मिलेगा ना. थीटा कैलकुलेट करने का ही है हम लोगों को, पर थीटा कैलकुलेट करने के लिए एक साइड मिल जाए, एक और साइड चाहिए, तो कौन सा मिलेगा? PR मिलेगा या QR मिलेगा? बाय यूजिंग द ज्योमेट्री. सो बाय यूजिंग द ज्योमेट्री यार वी कैन कैलकुलेट दिस PR लेंथ. कौन सा लेंथ मिलेगा? ये PR मिलेगा. कैसे मिलेगा ये PR? यू हैव टू कैलकुलेट दिस PR.
सर
क्या
150 माइनस रेडियस.
सर 50 माइनस करेंगे नीचे वाला.
By using this base width of this container,
क्या आएगा सर? PR.
we can calculate this PR. यार, so this ये surface से लेके ये surface तक ये total distance है 150. यार, so this 150 minus this much distance and minus this much distance. Here you will get this PR. अभी ये डिस्टेंस कितना है? ये रेडियस इतना है, और ये डिस्टेंस इज इक्वल टू द रेडियस ऑफ दिस सर्कल. यार मींस हाउ मच इज दिस PR?
50.
It is 150 minus 50 minus 50. Am I right? Which is equal to 50 millimeter. Means in this right angle triangle, to calculate this theta, I know the adjacent side or hypotenuse. And if you know the adjacent side and hypotenuse, which trigonometric relation you have to use to get that theta? Cos ray. Yeah. So in that triangle, cos theta equal to adjacent side PR upon hypotenuse PQ. Here, so cos theta equal to PR is 50, PQ is 100, so theta equal to 60 degree. Okay, ये theta कितना आया? It is 60 degree. Here it is 60 degree. Here it is 60 degree. Any doubt? समझ में आया क्या अभी? यार, now for Q apply the Lami's theorem. Angle मिल गया. तीन concurrent forces है. यार उसमें से दो unknowns है. Yes, so using Lami's theorem, each force is proportional to the sine of angle between others two. So RD divided by, हाँ बोलो.
सर आपने जो Q P के रिस्पेक्ट में वो जो बनाया है उधर 60 डिग्री आएगा, पर जो Q के रिस्पेक्ट में बनाया है उधर 30 डिग्री आना चाहिए ना सर.
हाँ, ये 30 डिग्री आएगा ना.
30 डिग्री बन रहा है ना.
ये 30 डिग्री बन रहा है, ये देखो, यू मीन टू से ये 60 डिग्री है तो ये 30 डिग्री आएगा, राइट? ओके, तो ये 30 डिग्री इधर ना, डायग्राम में ना इधर ना, तो ये 30 आएगा ना, ये देखो ये वर्टिकल के साथ 30 है, इट इज द एंगल मेड बाय दिस लाइन PQ विथ वर्टिकल 30, तो ये 30 आएगा। मैंने ये 60 लिखा यार, मैंने ये एंगल लिखा देखो 60 डिग्री, और ये एक ही लाइन है ऐसा, अगर ये 60 है तो ये अल्टरनेट एंगल तो ये 60 होगा। 30 लिखने का है तो वर्टिकल के साथ 30 होगा, 30 लिख के भी सॉल्व कर सकते हैं, बट डोंट गेट कंफ्यूज, इधर आपको हॉरिजॉन्टल के साथ 60 आ रहा है, सॉरी वर्टिकल के साथ 30 दिखा रहे हैं आप ये फिगर में, और इधर वो हॉरिजॉन्टल के साथ 30 लिख रहे हैं, तो रॉन्ग हो जाएगा ना। समझ में आ रहा है क्या?
यस सर।
ओके क्लियर, लिसन, अभी इक्विलिब्रियम और फ्रिक्शन में सिर्फ ज्योमेट्री है क्लियर, अगर ज्योमेट्री कंफर्टेबल है ना, बोथ टॉपिक्स आर वेरी इजी, क्योंकि मैकेनिक्स का कंसेप्ट बहुत कम है क्लियर। तो RG डिवाइडेड बाय साइन ऑफ एंगल बिटवीन ऑफ टू, RG डिवाइडेड बाय साइन ऑफ एंगल बिटवीन ऑफ टू, हाउ मच इज दैट? sin 90, which is equal to RC divided by sin of angle between of those two, how much is the angle between of those two? 90 plus 60, 150, which is equal to 200. अभी देखो, here all the three forces are directed toward the point, so no need to make any change. यार, और लैमिस थ्योरम में ये फोर्स डाउनवर्ड है, इसलिए माइनस मत यूज करो, लैमिस थ्योरम में वो साइन कन्वेंशन एप्लीकेबल नहीं है, यार दैट साइन कन्वेंशंस आर एप्लीकेबल फॉर कंडीशंस ऑफ इक्विलिब्रियम। लैमिस थ्योरम में सिर्फ एक ही कंडीशन है कि ऑल द थ्री फोर्सेस शुड एक्ट टुवर्ड्स और अवे। Yes, so 200 divided by sine of angle between of those two. How much is that? 90 plus 30, 120. Sine 120. Equate first and third RD मिल जाएगा, equate second and third RC मिल जाएगा। Any doubt? Yeah, write your name and roll number in the chat box for the attendance. Okay. कितना है RD? How much is the reactive force at point D?
230.94.
230.94 and RC इसको मल्टीप्लाई बाय 150 कर दो, क्योंकि साइन 90 तो 1 ही है, मतलब ये 230.94 इसका आंसर आ गया। डायरेक्टली आंसर मल्टीप्लाई बाय 150 कर दो तो RC मिल जाएगा
115.47.
115.17
115.47.
115.47 Newton. Don't forget to write the unit. Okay. Now use that RD here. It is 230.94. Now and apply the condition of equilibrium for this P. क्योंकि P में अभी कितने फोर्सेस है? 4 है, 1 2 3 4. Here you cannot apply the Lami's theorem. You have to go for the conditions of equilibrium. Understood? Here for consider FBD of cylinder P. Yes, P का FBD कंसिडर करो। ओके यार, ये 60 है और ये RD है। अभी RD का मैग्नीट्यूड आपको पता है, इट इज 230.94। ओके यार, नाउ अप्लाई द कंडीशन ऑफ इक्विलिब्रियम। इसमें लैमिस थ्योरम नहीं अप्लाई होगा, यार यू हैव टू अप्लाई द कंडीशन ऑफ इक्विलिब्रियम। उसके लिए RD को रिजॉल्व करना पड़ेगा। यार अगर ये एंगल 60 है तो दिस एंगल इज 60 अल्टरनेट एंगल। यार तो ये कॉस कंपोनेंट होगा, ये साइन कंपोनेंट होगा। सिमिलरली लेट्स रिजॉल्व दिस RD इनटू टू कंपोनेंट। दिस एंगल इज 80, so this is cos, this is sin. Using the condition of equilibrium, first I will use summation of fx equal to 0. If I summation of fx equal to 0, RA minus RB cos 60, sorry, RB cos 80, ये component. This component is towards left, so minus, it is 230.94 into cos of 60 equal to 0. ये equation में दो unknown है, RA and RB. We cannot calculate the two unknowns. Don't simplify, ऐसा ही रखो and say it as the equation number 1. Then use summation of fy equal to 0. Here it is minus 200 minus 230.94 sin 60 and y component of this RB upward, so plus RB sin 80 equal to 0. अभी ये इक्वेशन में एक ही अननोन है RB. Use solve function, you will get RB. Substitute in equation number 1. Substitute in 1. you will get RA. Okay, any doubt? Any difficulty?
नो सर।
ओके, अभी देखो सम नंबर 11 हमने सॉल्व किया, सम नंबर 13 इज फॉर होमवर्क, सम नंबर 13 फॉर होमवर्क। ओके यार, सम नंबर 13 में क्या है देखो, आई एम ड्राइंग द फिगर ऑफ सम नंबर 13 ओवर हियर। यार ऐसा ही दो सिलेंडर है, resting in one container, one surface is vertical, base is horizontal, और ये surface incline है ऐसा, इसको टचिंग करके। ओके, सेम सिचुएशन है, अंडरस्टूड यार। लेकिन इसमें ये बेस विड्थ दिया था, टोटल हॉरिजॉन्टल डिस्टेंस दिया था, इसमें क्या दिया है, ये अपर सिलेंडर जो है उसका सेंटर का हॉरिजॉन्टल डिस्टेंस दिया फ्रॉम दिस सरफेस, ये वैल्यू दिया है 700। मतलब हम आप लोग जब इधर ट्रायंगल कंस्ट्रक्ट करेंगे तो ये जो डिस्टेंस आएगा, ये जो डिस्टेंस आएगा, इट विल बी 700 माइनस दिस रेडियस आएगा। ओके यार, 700 माइनस दिस रेडियस, ये रेडियस माइनस करने का जरूरत नहीं है। बट माय पॉइंट यार, अभी इसमें ये जो रिएक्शन इंक्लाइन आया था, अभी इसमें ये रिएक्शन वर्टिकल आएगा, ये हॉरिजॉन्टल आएगा, और यहाँ का रिएक्शन इंक्लाइन आएगा। इट वाज हॉरिजॉन्टल हियर। Here, so this sum is exactly similar to this sum. So this sum number 13 is for homework. Understood? Any doubt? In next lecture, we'll solve the sum on we'll study about the another support, here heel support, roller support, and fixed support, and we'll solve the reaction, beam reaction after this. Any doubt? Okay, now we'll stop here. Today, I think we have one regular lecture also. Okay, so if possible, I will conduct that lecture also. I will let you know. Thank you.